Bro, you know we rock with that Poland Spring water up in here. Let's do angles. Let's do circles. You already know the vibes. Last day of our MCAS review. Let's get it. All right, welcome. Let's talk about angles. So, supplementary angles. There are two angles that add up to 180 degrees. What we can see here is we have a straight line. A straight line that is cut through by, in this case, a ray that forms angle 1 and angle 2. And so since a straight line is 180 degrees, we know angle 1 plus angle 2 would equal 180 degrees. That just means that these two angles are supplementary. Well, what about complementary angles? Well, complementary angles are two angles that add up to 90 degrees. So if we have a right angle, this box here means that it's 90 degrees. And so that means if that right angle is cut through by a ray, then angle 1 plus angle 2 would equal 90 degrees. And so talking about vertical angles, they're opposite angles that are formed by two intersecting lines. Here we can see line 1 and line 2 intersect at this point. This forms four angles, and the angles that are opposite of each other are congruent. This symbol here means congruent. So that means angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And so if I go to the definition of congruent, that just means the measurement is equal, and this is our symbol for congruent. And so if angle 1 and angle 3 are congruent, that means the measurement of angle 1 and the measurement of angle 3 is equal. So if angle 1 was 82 degrees, that just means angle 3 would also be 82 degrees. Same with angle 2 and angle 4. And so just a quick jot here, a right angle is 90 degrees and a straight angle is 180. That's what we call this here is a straight angle, 180 degrees, a right angle, 90 degrees. Welcome everybody. So here we have our first angle problem. So example 1 says we have three lines that intersect to form six angles. 1, 2, 3, 4, 5, 6. The measures in degrees of some of the angles are represented in expressions as shown in the diagram below. Interestingly enough about this problem was on the 2022 MCAS. And when I look at this problem, and the first time I did this problem, I made this problem 10 times harder. Showed it to a friend, and they made it even harder than I showed them. And then when I sat down to do this video, I realized the easiest way to do this problem. And so when you're doing problems like these, whenever it's angles, what you should do is find all the vertical angles first. That's the easiest because there's a million ways to solve these problems. First off, find the vertical angles. What is opposite of 5x? Well, it's this angle here. So that means this angle is also 5x. And so if you're on MCAS, you probably want to recreate this on your scrap paper. So this way you can fill in your separate angles. And then obviously here would be our next right angle because they're vertical. And so what I like to do is I like to highlight each line with a different highlighter. So this one can be orange. This one can be yellow. And finally, our last line, we can make green. And so what we can see here is that the right angle that we had here was green and orange. This right angle is also green and orange, so that means these are definitely vertical. Here is green and yellow, and then below here is also green and yellow, so that means these are vertical. And again, orange, yellow, vertical. And so based on the diagram, write an algebraic equation that can be used to find the value of x, show or explain how you got your answer. And then solve for x. So if we want to solve for x and find x and write an equation, first off, let's figure out where x is. X is right here. And so when we look at this, we need to look for a straight line. What we see is this yellow highlighted line. We can see that on that yellow line is 1, 2, 3 angles. And so this box means 90 degrees. So that means these three angles is equal to our straight line. Our straight line is 180 degrees. So that means I could just do 5x plus 90 degrees plus 40 degrees. And again, these three angles were on our straight yellow line, which is equal to 180 degrees. Now we can add our constants together. So 90 plus 40 gives me 130 degrees. So now we're solving for x. And so what that means is 5x plus 130 is equal to 180 degrees. And here's our equation. Now the second part is we can solve for this equation by doing a two-step. So I subtract 130 from both sides. These are additive inverses, so they cancel out, and I carry down my 5x. That's equal to 180 minus 130, which is just 50. And we can clearly see that when we divide both sides by 5, x is equal to 10. And so what's the measurement of our angle? Well, if it's 5x, you do 5 times 10, which is equal to 50. That just means that this 5x is equal to 50 degrees. And so based on the diagram, for our second part, based on the diagram, write an algebraic expression that can be used to find the value of y, show or explain how you got your answer, and then solve for y. This problem is actually a lot easier than solving for x. Why? Because we can see that these two are vertical. What we learned from our notes is that vertical angles, if I go back up here, where is it? Right here. Vertical angles are opposite angles and they're congruent. Congruent means the measurements are equal. So what is the opposite angle to 3y plus 1? We already said that earlier, but if I was to color it in, we can see that 3y plus 1 is actually congruent to 40 degrees. That means the measurements are equal. So I can set up the equation as 3y plus 1 is equal to 40. And so if MCAS just asks us for a box, right, that's what you put in. And then you solve for y by explaining your work. In this case, we then just want to solve for y. And so we subtract 1 from both sides. Bam. And so carry down 3y is equal to 39. Divide both sides by 3. We end up getting y is equal to 13. And that was the answer to the famous 2022 MCAS problem. So always look for your vertical angles. Always try to figure out how you can write your expression. Solve for x. Most of the time, you're going to have to plug that back in. Let's go to our next problem. All right, welcome. We have one more angle problem. Here we can see angle ABC. And also, we always read an angle as the order, so ABC. The angle we're talking about is always the letter in the middle. And so that means that angle ABC is a right angle. And what we know is a right angle is 90 degrees. We're told that here. We want to solve for x and find the measurements of the angles. So if it's a right angle, that means that these angles are complementary. Bam. Why? They add up to 90 degrees. And so in order to solve for x, we're going to have to do angle ABD, angle ABD, plus angle DBC. Remember the angles in the middle, we go by the letters DBC. And again, this is complementary, so it's just going to equal 90 degrees. And so angle ABD is equal to the expression 3 times the binomial x plus 8. Remember, a binomial just means two terms. And so those two terms are in these parentheses, and both of the terms are being multiplied by 3. So this is 3 times the binomial x plus 8. We want to add that to our second expression, which is just 2x minus 4. And that's equal to 90 degrees. Why is this problem difficult? Well, it's because you're actually going to have to do the distributive property before you can combine like terms. So doing the distributive property means 3 is multiplying both of our terms. So we do 3 times x and then 3 times 8. 3 times x is just 3x. 3 times 8 is 24. And then we carry everything else down. And so now we can combine like terms. What's a like term? A like term is a term that has the same expression and exponent. I'm sorry, not the same expression. It has the same variable and exponent. For here, we see this 3x and this 2x both have a variable of x with an invisible exponent of 1. And so 3x plus 2x is just 5x plus 24 minus 4, right? This minus 4 can be seen as plus negative 4. So 24 minus 4, when we combine these constants, we end up just getting 20 is equal to 90. And again, we need to solve for x. So minus 20 minus 20, carry down our 5x is equal to 70. And then divide both sides by 5. X is equal to 70 divided by 5, which is equal to 14. And so now we're not done yet because we actually need to figure out what each of these angles equal. So maybe I choose the easiest angle, which could be either of them, but you do 2 times x minus 4. And so to get angle DBC, I can substitute x in with 14. And so 2 times 14 minus 4. So I can separate these. 2 times 14 is 28 minus 4 is equal to 24 degrees. And so we know that this angle is just equal to 24 degrees. And now I don't necessarily have to plug 14 in here for x. I can just do 90 minus 24. Why? Because they're complementary. And so when I do 90 minus 24, I just get 66 degrees. And you can double check this by doing 66 plus 24, and then you'd get the right answer. Welcome here for example 3 and example 4. We have the area of a circle and the circumference of a circle. And so the area of a circle is pi times the radius to the second power. R is equal to radius. What we can see is a picture of a radius here. And what we know is a radius is half the diameter. As for circumference, the circumference is equal to pi times the diameter, or some of you may know it as 2 pi r. D is equal to diameter. The diameter is double the radius. This makes sense because, like if the radius is half the diameter, the reciprocal to a half is to double, which is why the diameter is double the radius. So here we have the diameter of our circle, and we can now solve our problems. Our first problem talks about the area. A mirror is in the shape of a circle as shown in the diagram. Here we have a diameter of 18 inches. Based on the dimensions, what is the area? What we know from our area formula is that it's pi times the radius squared. That tells me we need our radius. So if our diameter is 18, our radius is half our diameter. What is half of 18? Well, half of 18 divided by 2 is just 9. And so if that means our area is equal to pi times our radius squared, that would be 9 squared. So 9 squared, or 9 to the second power, just means 9 times itself. And so 9 to the second power can be rewritten as 9 times 9, which is just equal to 81. Quickly, the inverse to squaring a number would be to take the square root. So the square root of 81, right? The square root of 81 is just whatever times itself is equal to 81, which in this case would just be 9. And so back to 9 to the second power, we already did it. It's 9 times 9. So our area is equal to pi times 81. And so we could just switch these and leave that as our answer. But in 7th grade, they want you to use 3 and 14 hundredths as pi. So if pi is equal to 3 and 14 hundredths, you need to do 3 and 14 hundredths times 81 to get your approximate answer. What you need to remember too is the area is talking about the inside of your shape. And so if I have 3 and 14 hundredths on top times 81, again, we're gonna have to add back our 2 decimal places here into our product. So let's keep track of that. So 1 times 4 is 4, 1 times 1 is 1, 1 times 3 is 3. I am moving a place value over to the tens place, so that means I need a placeholder. 8 times 4 is going to be 32, so we regroup our 3. 8 times 1 is 1, plus 3 is 11, regroup our 1. 8 times 3 is 24, plus 1 is 25. And so we add these 4, 3, 4, 5, 2. Again, we have to add 2 decimal places back in. So we go to the left 1, 2. And so that means the area is going to be 254 and 34 hundredths inches squared. Bam. And so again, with these problems, you need to do your area formula. Luckily for circumference and area formulas for circles, I'm pretty sure they usually come up as with a calculator. So this is more or less just for review on how to multiply a decimal with a whole number. And so here we have Kyle used wire fencing to form a border around a circular region in his backyard. If the radius of the circular region was 5 yards, what is the total length of the border? So these keywords border and circular tell us that we're looking for the perimeter of our circle. The perimeter of our circle is the outside space, which we use a special term called circumference. So we actually need to use our circumference formula. So here our radius is 5, but our circumference formula says we need to do pi times our diameter. And so 5 is not our diameter, 5 is our radius. And so what we need to remember is our diameter is double our radius. So what's double of 5? What's double of 5 is 10. That means our radius is 10. And so our circumference is equal to pi times 10. And so if we say pi is just 3 and 14 hundredths, you can do 3 and 14 hundredths times 10. Some of you may know that you just bring over the decimal place once when you multiply by 10, but we're going to show you why you can do that. So again, 0, 0, 0, because 0 times 4 is 0, 0 times 1 is 0, 0 times 3. There's 2 decimal places. You skip over a place value because you're moving over to the tens place, and then 1 times 4, 1 times 1, 1 times 3. You bring it over 3, 1, 4, 0. We're moving over 2 decimal places, so that's 1, 2. Our answer is equal to 31 and 4/10 yards. And so that means the border of our fence is 31 and 4/10 yards. And now this was area and this was circumference. What made this area is it blatantly asked for the area, or if it said what is the space inside your circular region, that would be your area. This problem here, it asks for the border, which is the outside of your circle, which is just your circumference. And that was circles, y'all.